Assalamualaikum warahmatullahi wabarakatuh. My name is Nifar Auni binti Muhammad Kamal Hasmadi, matric number 1190968. So today I would like to present about segmentation image processing on brain and liver tumor. So I will start with the introduction with the definition of tumor, which is a mass of tissue that develops abnormally when cells do not die on schedule or expand or divide more often than they should. So the parts of body that can be affected are bone, skin, glands, tissues, and organs. So these are the few treatments done to prevent tumor from growing and affect other neighboring cells. First one by surgery to remove the tumor. That's why it's chemotherapy to shrink the tumor before surgery and destroy the lingering abnormal cells after the surgery is done. And next one is immunotherapy, which is a cancer treatment that activates the immune system. And recently, FDA authorized a combination of immunotherapy medications, which are Imfinzi and Imjudo, for patients with unresectable hepatocellular carcinoma, the most prevalent liver cancer, on October 2022. And last one is radiotherapy, which uses radiation to kill the abnormal cells. And uh, for addition, the cancer cell growth also can be slowed down and stopped by target therapy. So following to do this treatment mentioned before, the cancer or tumor cells must be identified first, must be localized first, so that when we're doing the treatment, we only targeted the correct cell. Okay, so the most frequently used radiographic methods for diagnosis or for treatment planning are CT, computed tomography, and MRI, magnetic resonance imaging. This technique used for segmentations of medical images are specific to type of body part to be treated, application, and also imaging modality. However, each imaging system has its own specific limitations. For example, in MR imaging, um, we have to take care of the bias field noise manually. So, but MRI is an innovative medical image processing method for visualizing of the internal structure of body, and it can also produces ultra resolution image of the body parts. So MRI image segmentation is being helpful to localize accurately the cancer cell. And deep learning has a crucial role for detection of brain tumors. There are several algorithms, for example, to do the image segmentation, for example, thresholding method, region-based segmentation, fuzzy clustering, K-clustering, K-means clustering, neural network level sub method, and outsource method, and also watershed algorithm. So moving on, segmentation of a brain tumor. Okay, image segmentation of brain tumor. Detection can be observed from different parameters such as accuracy, precision, recall, and response time. So for the clustering technique and SVM, which is support vector machine, when using this technique, the accuracy and precision of tumor are increases, which with the classifiers were able to detect 7 features, and SVM proved with 94.6% accuracy. And also Ratan reviewed different methods for tumor segmentation with combining SVM thresholding with SVM or Bayesian by using median filters, thresholding, and morphological operation to detect the tumor. So, okay, moving on to the next one is level set method. Level set method for brain tumor segmentation is rationalize. They rationalize the threshold values of images and adjust it automatically for our MR images. All right. So the next one is outsource method. This method is actually a global threshold, means that uh, the output we can see after doing this is only on gray value of the images. And from MATLAB, we can see it as gray trash, which expansion by choosing the threshold to minimize the intraclass variance. Okay, its function is by choosing the threshold to minimize the intraclass variance of the threshold black and white pixels. So, so after doing the uh, after we doing the uh, gray level histogram or greatly enhancing thresholding speed and improving noise immunity, an image set of contour was extracted as a result of segmentation. So what with adjacent regions are noticeably different with respect to the same characteristic. Every pixel in a region is similar with respect to some characteristics such as color, intensity, or texture. The contours produced after image segmentation is in 3D reconstruction when applied to a stack of images. After that, the tumor can be represented. Can the tumor, brain tumor is segmented and can be represented in a white color. So I'm moving on to the segmentation of liver tumor. Okay, so steps used are thresholding, distance transform, watershed transform, and display watershed. This actually included in segmentation based on age and calculate number of pixels for statistical analysis and morphogenic segmentation. So for further explanation, first, the image is acquired using an image acquisition, and RGB image will be converted into grayscaling for threshold. Then auto threshold method computes the ideal threshold for the image before applying it to the image. There's operations are carried out in binary. Then by using Danielson's algorithm, uh, it will undergoes gradient image processing, and the watershed transform on an image is then compute by watershed transform. And then lastly, threshold and mask are used to display the watershed line. So this process is actually boundary-based method for local change and region-based method that compare pieces with region. So so on images where object shapes are used as basic for segmentation, this function also applied, and this process is completed the segmentation process, analysis of the liver cancer image, then watershed lines aid in detection of cancerous tissue. Next one is kernel-based extreme learning machine. So this method is detect and segment liver tumor voxels in CT scan is faster compared to support vector machine. So for this one, the features of voxels on triplane are generated and ELM, extreme learning machine training data set is built in this feature. Each voxel is labeled as either tumor or non-tumor class with proper threshold selection for classification result. After that, a tumor sampling is applying into the space and expand the voxel's feature representation. With this, we can differentiate between the non-tumor and the tumor cells. Okay. That's all for the kernel based explanation. That's all for me. Thank you.